Well, hello physics folks. Welcome to Doc Onco's Physics. Keith Onco here. What we're going to look at today is another problem having to do with Newton's laws, where we're trying to figure out what the mass of an elevator is if the elevator is pulled up by a cable with a force of 65,000 newtons. The upward acceleration of the elevator is 1.8 meters per second or 1.8 meters per second squared. And again, we want to know what the mass of the elevator is. So what are the equations we're going to use again? All right, these are the only real two equations that we have. The sum of the forces equals ma, and frictional force. Well, we have no friction in our elevator, so that one's not going to really apply. But we certainly do have forces on our elevator. Okay, so first of all, we're going to say that we have the mass of an elevator right here, and we want to figure out what that mass is. So we're going to draw all the forces that have to do with the elevator. Right? So what's one of the first forces? Well, because our elevator has mass, it also has gravity. All right, so we're going to have the force due to gravity on our elevator, which is going to be the mass of the elevator, right, times 9.8 meters per second squared. Okay, the fact that we're drawing it in the downward direction, right, gives us that negative vector, and so we'll include that negative sign when we put that into our equation. Right, so I'm not putting the negative sign right in here. Right, I'm going to put the negative sign in the equation itself. All right, so the elevator is being pulled up by a cable with a force of 65,000 newtons. So we have a force due to tension up here that's 65,000 newtons. Okay, and it also states that the acceleration is in the upward direction, and that is equal to 1.8 meters per second squared. All right, and those are all the numbers that we have. So what can we do now? Well, we've identified all the forces. We've identified the acceleration on our elevator. Let's write an equation. Right? What do we got? Well, the sum of the forces on our elevator are equal to, and again, this is in the y direction now. We have no x direction forces. Some of our forces in the y direction are 65,000 newtons minus the force due to gravity, which is me times 9.8 meters per second squared, is equal to the mass of the accelerator, which is what, the elevator, which is what we're looking for, times the acceleration of the elevator, which is 1.8 meters per second squared. Okay, so there's our equation. Unfortunately, it's kind of smushed over on the right-hand side. I'm going to rewrite it over on the left-hand side. So what do we got? We have 65,000 newtons, right, minus me times 9.8 meters per second squared is equal to me times 1.8 meters per second squared. All right. Well, the first thing I'm going to do is I'm going to move the terms with me over to the right-hand side. I'm going to collect those together. So I have 65,000 newtons is going to equal me times 9.8 meters per second squared plus 1.8 meters per second squared. All right. So the negative, this negative over here, all right, became a positive when I brought it over to the other side. So we've got 65,000 newtons is equal to me times, and what we have is a total of 11.6 meters per second squared, and we divide each side by 11.6 meters per second squared. Me turns out to be about 5,603 kilograms. Okay, and so, you know, it's really that simple in solving a problem like this. The problem that students get into is that they see something like this, and it's an elevator, it's accelerating, it's got this and that, and we don't follow the process. Right? There's a strict process to solving these types of problems. One is to identify all of your objects, right? Two is to draw free body diagrams, right? Free body diagrams, or identify all forces on that on each object, right? Which we did, okay? And then three, write our equation and solve, okay? And if you do that and you don't skip any of the steps, you'll be successful. I hope that helps. Have a great day.